This is the session 6 of the 5B model, that is the earthquake resistance design of masonry buildings. So in this today's topic, it is covered with the retrofitting of masonry buildings. So whatever the different methods are there for the retrofitting of the masonry, so actually the choice of suitable method of retrofitting basically depends upon the structural scheme and the employed building materials in to prevent the construction along the with a feasible and economical technology is concerned. Moreover, an understanding of failure mode, structural behavior with the weak and strong aspects of design as derived from the earthquake damage survey also the influence the selection of the retrofitting schemes. So numerous techniques used to retrofit the seismically deficient or damaged masonry buildings may be broadly classified into three categories on the basis of their effect on the structural performances. Namely, for improving the existing masonry, whatever the strength and deformity do not relate to any specific objective which is similar to the repairing process of the masonries are concerned. And second one is the improving the in plane strength of the walls or any weak zone of the section to a local or a member retrofitting. Then third one is the improving the structural integrity of the whole structure in terms of in plane and out of the plane strength or only against out of plane forces, a very much like the global structural or a retrofitting various techniques under these schemes. What we can generally say that the repair or a local or a member retrofitting or the structural the retrofittings are concerned. Now as far as the repair is concerned, so it is a process to improve the mechanical efficiency of masonry structures and to increase the shear resistance of the wall along large internal voids. The commonly employed repairing of the techniques employed for the masonries are cement or epoxy injection, and next one is reinforced injection. Then third one is grouting with cement or epoxy. Then fourth one is insertion of the stones. Then last one is repointing of the mortar is concerned. Then as far as the local or a member retrofitting is concerned, so it will be enhance the shear resistance of the unreinforced masonry components, especially against the in-plane forces are concerned. Then feasible retrofitting techniques are number one surface coating, number two shotcreting overlays or the adhered fabric with the wire mesh or the FRP material. Then last one is use of RC and steel frame in the openings are concerned. Then the next one is the structural or global retrofitting is consist of improving the response of existing unreinforced masonry building to both gravity and seismic load. It provides the box type of behavior and increase the flexure strength of unreinforced walls and piers. The most commonly applied the techniques are the addition of reinforcement, external bending or jacketing. Then third one is pre-stressing. Fourth one is confinements with the RC elements and steel section. Then fifth one is strengthening of wall intersection. Then sixth one is strengthening of the connections between the walls and floors are concerned. Now as far as the repairing techniques of masonry is concerned, actually the repairing of the cracks or replacement of the damaged wall sections is an essential feature of the repairing process. It is a general assumptions that the repairing only helps to retain the original shape of the structure without increasing its strength. The two main whatever the problems solved during the repairing processes are: number one, masonry cracking, and number two is masonry deterioration. As far as the masonry cracking is concerned, in general, the crack may be defined as break, split, fracture, fissure, separation, cleavage, or elongated narrow opening visible to the normal human eye, and extending from the surfaces and into a masonry unit. The matter joint or interface between the masonry unit and adjacent mortar joint, or into a joint between the masonry and adjacent construction element. Beside that, the seismic vibration that cause the cracking is a moment or a strain induced by imposition of the loads. So, or by the restraining of the volume changes in the masonry materials, then nothing can help to prevent such cracks, but at least they may be accommodated. In the case of the load bearing masonry buildings, the seismic damage depends upon the width of the crack, for which repairing process need to be defined accordingly. Then the whatever the repairing techniques are there. So the approach for adopting to repair process of existing or a damaged masonry principally relies on the basis of level of the cracking. It may be a repair of G0 and G1 grade type of the cracks. So here the whatever the repair cracks are there up to 5 mm, the pressure injection of cement grout containing the admixture against shrinkage or epoxy is recommended. For fine cracks up to 1 mm width, then epoxy injection is preferred. The whatever the procedure is there, okay, so which we can see it as per the IS 13935, and the general steps are as below. The first one is clean the external surface of the wall from the non-structural material. Then place the plastic injection along the surface of the crack on both sides of the member, and also secure a place with the fast binding mortars. Then the center to center spacing of these port may be approximately equal to the thickness of the element. Then next step is, after the sealant has cured, inject the low viscosity epoxy resin or cement grout into one part at a time, beginning at the lowest part of the crack. In case it is it is a vertical, or at one end of the crack, in case it is horizontal. Then next step is the process of injecting are to be continued until the epoxy resin or a cement grout penetrate into cracks. Then the injection portion should be closed at this stage, and the injection equipment next port, and so on, like that the procedure is to be carried out. Now in this figure, it shows that the repair of how the G0 or a G1 grade of the cracking, and how this grout or epoxy injections is employed in the cracks, and also the cement mortar or a flat chip which in wide cracks, how it is to be done. So here the figure itself will give the complete information of how this the repairing for the G0 and G1 grading of cracking is to be executed. Now as far as the repair of G2 type of grade cracking, so in G2 grade of cracks, the repairing process remain much similar to the previous whatever we have seen the techniques, with the exception to insert of the reinforcement in every injected hole. The step is to be followed as per the codal provision of IS 13935 for repairing of the cracks. The here in the figure you can see the how this repairing is to be carried out for the G2 grade of cracking. For the cement mortar, wire mesh in the crack as per the codal provision. First, remove the loose material as usual and place the either epoxy or sand mortar or quick setting cement mortar. Then provide the additional reinforcement if necessary and cover with the mortar. In case of damage to the walls and floor diaphragms, then steel mesh to be provided on the outer surface and nailed or a bolt to the wall. Then it may be covered with the plaster or the micro concrete is concerned. So which we can see it from the figure. So in case of much larger cracks, then units become loose and repairing process has to be more extensive than the injection. So in the that case, it is defined process as remove the crack unit and insert a new unit in rich mortar, or use steel bars or a stitching dogs to fill the voids. And same procedures can be continued on the opposite side of the all the walls if necessary. This the figure how it will looks, the procedure of the repair is to be carried out. Then repairing of G3 grade of concrete cracks. So here the cracks due to loss of connections among the multi width masonry walls may be categorized as G3 grade of the cracking. The multi-width wall the construction practice is a frequent in rural and hilly region of the our Indian country, with a stone masonry houses built with poor mortar. Such wall construction happen to be more sustainable to out of plane forces, resulting into collapse of the out of leaf of multiple leaves stone masonry walls. There may be two possible of the damage. The first one is the permanent distortion of the wall on the both sides, whatever we can see it in the figure A, and distortion on the humping only on the side as shown in the figure B. The first case only the distressed portion of the wall may be removed and reconstructed. Such repairing is not feasible. So in a second case, total reconstructions may be avoided by removing only the humped side of the rebuilding the wall and filling the voids with concrete or cement ground. Then the insertion of thorough stones and bond stones at regular intervals, which you can see it in figure C, maybe provide a good construction connection between the reconstructed wall and the existing wall. The whatever the repairing process is like which we can see it in a figure. So the first one is a throw stone or a bond stone. In the event of the earthquake, delamination and bulging of the walls, then the vertical separation of internal or external wire through the middle of the wall thickness generally occurred in a stone masonry construction. So here the whatever the constructions may be preferred in one of the layers is suitable enough to be used as a framework. These throw stones full length equal to the wall thickness may be inserted at an interval of 0.6 meter in vertical directions and 1.2 meter in horizontal direction, where you can see it in a figure A, this one, first one and second one. So in the non-availability of the full length stones, then stones in pairs such as about 3/4 of the wall thickness may be used to provide the overlap between them. The techniques includes the preparation of space in the wall and the insertion of the stones of equal size to the thickness of the wall and fixing of the stones with cement sand mortar. Other alternatives of the throw stones are used as type of shape elements of the steel bars of 8 to 10 diameter, or hooked link with a cover of 25 from each face of the wall, or the wooden bars of size 38 by 30 cross sections are equivalent, which we can see it in the figure. Next one is here the cement grouting is concerned. So here the groutings are most the frequently used to repair and strengthening of the masonry walls having large voids or to fill the space between the adjacent portion of the masonry. There may be different types of grout, but most commonly used type are epoxy and cement grouts. Then the grout injection binds the inner and outer wires together, establishing a composite action between them for an improved out of plane moment capacity. The selection of grout depends on the desired strength, bonding properties, and the size of the crack network or wire system. Then the fine grout can fill the cracks as small as something about a very micro level is concerned. While the coarse grouts are useful to filling the wide this one collar joints between the whites. The whatever the cement grout consists of one part of Portland cement and half a part of type of S type of hydrated the lime or half part of fly ash may be used for repairing the earthquake damaged in the unreinforced masonries are concerned. Then the masonry, the deterioration is concerned. So here the phenomena of masonry deterioration is somewhat unrelated to the earthquake, but it repairs is required to be done along with the repair of the cracks of walls. The most common type of masonry deteriorations are units due to water penetration and freeze thaw cycles and in mortar due to poor quality. Now the repairing techniques employed for the units, mortar and repointing. As per the unit is concerned, all the damaged units are replaced by new units of same appearance and material property. Then mortar, then there is a evidence that the weak the whatever the deteriorated mortar is the cause of failure in plane as well as out plane of masonry buildings. It is suggested that before taking up the retrofitting of building, improving in the strength of mortar is also necessary. Then the repointing is nothing but oftenly carried out when the quality of the mortars happens to be poor, but the units remain in good condition. This involves removal of the existing the mortar up to one third of the wall thickness or at least 3-4 inches from the joints on the one both sides of the walls, followed by the proper cleaning of surfaces by compressed air brush or steam water and insertion of new mortar. If the mortar condition is extremely poor, then removal is needed up to larger depth. Then steel reinforcement sometimes placed in bed joint to improve the ductility and energy dissipation capacity of the structure. The joints are then repinned with the cement mortar. Then after sufficient strength of the mortar is attained, the procedure of repointing is repeated on the either side of the wall. So this figure shows that how this various the repointing steps are to be carried out. So here how this different the figures itself will indicates that how this procedure of the repointing in brick masonry is to be calculated. Then next one is the member retrofitting. So in the member retrofitting, it is consist of the shotcrete. Okay, whatever the retrofitting technique is there, here the shotcrete. So in case of weak masonry and absence of enough the solid pier to resist the seismic loads, then the shotcrete is ideally suitable for the unreinforced masonry buildings. A considerable number of load bearing and the architectural unreinforced masonry walls have to be strengthened against the seismic motion by applying a layer of shotcrete either to the outside or inside of the surface of the wall. Shotcrete is a concrete mix pneumatically applied to a solid surface, what we can see it in a figure number A. So there are two types of shotcrete usually employed, namely wet mix for the large volumes and the massive sections are concerned. Then the dry mix are a it is under dry mix is called as a gunite for the lesser volumes for a thin sections and the confined spaces are concerned. Then better control can be achieved in handling of the dry mix shotcrete as compared to the wet mix due to good control of the material flow. Moreover, design of the concrete mix, selection of correct process and skilled workmen are essentially it is for the effectiveness of the shotcrete is concerned. The figure is giving the informations of how this new reinforced concrete and shotcrete is added to the existing unreinforced masonry, and as well as in plan how the shotcreting rib we can see it in the figure. Now, the structural overlay or the adhered fabrics. So, whatever the fiber reinforced plastic, usually we call as a FRP, has drawn the considerable attention for the repair and retrofitting of the civil engineering structures due to their unique properties like high strength to weight ratio, then stiffness to weight ratio, corrosiveness, and the fatigue resistance at against the conventional materials of heavy mass and limited efficiency is concerned. Now, FRP consists of a stiff and strong reinforced fiber. Primarily, it's a carbon and glass held together. There are various examples where the FRP has been successfully used for the retrofitting of RC structures. Use of added whatever the fabric materials like carbon fiber reinforced plastic, usually called as CFRP sheets, and also glass fiber reinforcement polymer, usually called as GFRP sheets are the latest developments as the medium of retrofitting of these structures are concerned, RC structures are concerned. The method of strengthening of the unreinforced masonry walls with FRP is a quite simple and is a rapid. The surfaces should be roughened first by grinding and then cleaned with the high air pressure, and holes are filled with the epoxy mortar. Then the small holes are filled with the epoxy resins. The FRP sheets are fixed to the surface of the masonry, the whatever the substrate by the epoxy resin. Then the crosswise on the one or both side of the walls. Then the steel plates are used to ensure the non-occurrences of anchorage failure and then anchoring the FRP to the slab and foundations, what we can see it in this figure. So that showing the various components for the strengthening of existing masonry walls with the FRP. Now the whatever the RC and steel frame concept is concerned. So in plain strength of masonry walls reduced due to openings, it may be increased by employing the techniques with consist of making RC or a steel frame inside the opening. The weakness of the wall caused by the openings can be effectively contracted by the frame. For better results, better interaction conditions are ensured between the wall and the frame. Whatever it is, the figure is there. So, which is show the complete procedure of how this strengthening technique of a opening in a unreinforced masonry wall using the reinforced concrete frame and also adding the reinforcement bar at the edges of the openings are concerned. So this is all about how this different retrofitting techniques to be used for the masonry buildings are concerned.